Welcome to Homework Lib.
Over here what we're going to have is that the reaction A plus 3B that is going to produce 2 of C is going to have initial amounts of mole, everything that I'm going to put in here is going to be in mole, of 0.352, 0.402, and 0.446. What we know of this reaction that is going to be occurring on both directions, because we can establish an equilibrium, what we know is that at the very end, we're going to have 0.378 mole of C at equilibrium. So we don't know what is going to be the amount of change, but what we can say is that the direction of the reaction is going to be going towards the left. So we can proceed by finding the amount of change that is going to be minus 2x in the case of C, that is going to produce 3 of x on B and plus x on A. So the equilibrium values of amount of mole for A and B are going to be 0.352 plus x and 0.402 plus 3 times x. So how do we know the value of x? Well, we can find it from the equilibrium amount of mole of C. This is going to be 0.446 mole minus 2x is equal to 0.378. So the value for x is going to be equal to 0.446 minus 0.378 divided by 2, which is going to be 0.034. That means that the equilibrium amount of mole of A will be 0.386 mole. The amount of mole of B at equilibrium is going to be 0.034 times 3 plus 0.402 gives us 0.504 mole of B, and the equilibrium amount of mole for C is the one that was given to us in the problem. With this, we have already solved part A of the problem. And now for part B, we want to know what is going to be the equilibrium constant. For the equilibrium constant, we're going to require the concentrations for each of the compounds. So the equilibrium concentration of A is going to be equal to amount of mole of A at the equilibrium divided by the volume. The volume is going to be equal to 1.5. So I'm going to repeat this procedure for each of the 3 compounds. And essentially, the only thing that I'm doing is dividing the result by 1.5, okay, from the amount of mole. So the equilibrium concentration of A is 0.2573 molar concentration. The concentration at equilibrium for B is going to be 0.504 divided by 1.5 liters, 0.336 molar. And the equilibrium concentration for C is going to be equal to 0.252. So now our equilibrium constant, Kc, is going to be, according to our chemical equation, concentration of C squared divided by concentration of A and concentration of B to the cube. Replacing the equilibrium values that we just found, the result is going to be 6.5. Well, 6.5056. In this case, you can round it up directly as 6.5. But depending on your professor, he's going to ask you a different amount of significant figures. In this case, all of the quantities are going to have 3 significant figures. So the value for Kc up to 3 significant figures is equal to 6.51. So with that, it would be all. Thank you very much, and have a good one.